Yeah, I welcome you for the next section of the subject of the thermodynamics one. In the last class, we are done with the outcomes objective of the subject, and now we'll go through the actual introduction of the subject. Right, coming to the thermodynamics, the basic definition, as I told you in earlier class, thermodynamics is nothing but it can be defined as a science of energy, in which nothing but these energy can be viewed as an ability to cause some change. If you put in a simple way, like if there is a duster which has been put on a table, if you want to lift the duster and put it into the another table, you have to lift the duster and you have to put. So in order to make some cause or some change, you generally require an energy. So in that way, you can define it a simple way. Already in a schooling level itself, in the basics, you have learned about the energy and all those things. So here, the thermodynamics is nothing but the study of energy, which actually used for the transformation from one form to the another one. Where the physical properties of substance like solids, liquids, gases, which is all involved in your energy use of transformation. Basically, the word thermodynamics is a Greek word, which is already told you, which has been taken from the Greek one, which if you interly subdivide the thermodynamics as thermo and dynamics, but thermo is nothing but the heat and dynamics is nothing but the power or the force. So put together, we say it as a heat force or heat power, which is most uh, dissipative efforts to convert the heat into power. And one of the most fundamental laws of the nature is the conservation of energy principle, which already we have learned in your schooling levels, which simply states that the interaction of the energy can change from one form to another, but the total amount of energy which remains constant. That is, energy cannot be created or not be destroyed. I'll show you with a live example by going through. uh, See, these are all the unit one which have divided into three modules. Module is nothing but the basic topic in that. Here we have three modules: module one, module two, module three. See, module one is nothing but we have the basics concepts of the subject, such as like system, surroundings, property, process, all comes under the module one. And module two is nothing but the temperature, measurement of the temperature, different thermometers. And module three is the perfect gas laws, where you have the Dalton's law, Boyle's laws, and all those things. So coming to this module one, I have divided with the outcome and as well as the objective over here. The previous slide which I have seen for the complete unit of the outcome, and this outcome is for your particular module. This is for the first module where you can explain several fundamental concepts. Just a moment, actually, I need to share the screen. Just a moment. Excuse me. Oh my goodness. Am I there? Sorry. It is not as. Yeah, these are the contents of your module number one, and these are the outcomes which are for the module number one. I'm not going to read out and waste your time on all those things. Directly and move on to the example, which I have listed over here. See the figure, if you can observe. If I zoom it here, see there is a hill which has been given over there, and there is a rock which is present at the top, in which the potential energy of the rock which is generally present is 10 units and the kinetic energy is 0. When you allow the rock to come down, when you throw it, when the kinetic energy which is generally present was usually zero, now it has been gained from the potential energy, which transform the potential energy as 7, kinetic energy as 3, which is balancing the energy, which is nothing but your conservation of energy principle. And next you have another figure, if you can observe over here, a person who is from the, you can observe the yokozuna from the wrestling and all those things. So if the energy input which has given us 5 units over here, and let me take the spotlight, and then we can explain you in a beautiful and easy or simple spotlight. Yeah. So here, if you observe the figure, the energy input which is given over here is 5, and the energy out which is going over is 4 units. So the 1 unit which is there, the balance is inside the that particular person. So this 1 unit has been consumed as energy storage, which actually builds your body, which stores as a fat. If you take a particular person who continuously consume the food and he doesn't have any kind of physical activity, then the body grows by in form of the storing as a fat. If you take another person who actually consumes the less amount of food and does more amount of work, he becomes thinner. So there will be definitely a balance of energy which takes place. So I request everyone to have some kind of physical activity at for your particular age. And next, if we come another example, there is a hot coffee which is given over here, the figure. This hot coffee, which is the temperature is usually was 70 degrees Celsius, and if you place it on a table in your normal room, what happens is like atmospheric air which is generally present over there, it comes in contact with your coffee, and then it brings your hot coffee which is at 70 degrees centigrade onto the normal cool environment onto the 20 degrees centigrade. How does it happen? That we'll explain in zeroth law of thermodynamics in the later class. So this is a consequence why this spontaneous process is happening, turning of your hot body into cold body. Why your cool body doesn't turn into hot body? It cannot happen because of natural process which takes place in a nature. If you want to do it, you should have some additional source to give it to convert your cool body into a hot body. That we'll learn in a heat engine and heat pump in a second law of thermodynamics when you want to unit number 3. So this is a direction which it follows, that laws gives you a second law of thermodynamics. So this is another example. If we can list out for all these examples, if I move on to the next example, there is a few questions which is given, like what is engineering all about? Before that, let me put this definition, which is very difficult to answer this question, but let me make an attempt to do this. Let us say one side we have a nature, and another side we have a humans. This nature is providing all the resources like water, air, solar energy, which all this kind of stored energy is in the form of the fuel. And you have many minerals also. We want, major aim is the good life. These good life can be produced with the help of the natural usage of your resources and minerals, converting to good life. The saga has been actually started olden way back when the ancient civilization, when man has initially started to know the fire by making a two stones rubbing. From there, the civilization has been started with the basic understanding of the science. Thermodynamics is nothing but everything, the nature laws which has been given, the solar system which has been evolved, the universe which has been evolved, how the planets evolving, everything is a basic understanding. The amount of flow of energy which has been taking place from the higher level energy level to lower energy level, the water coming from the top which flows onto the bottom to the ground, it doesn't takes place from bottom to flow onto the higher, from lower energy to higher energy, it doesn't takes place, right? Because that is avoiding the nature loss, it doesn't happen in the nature. So all these are the examples of your thermodynamics itself. So this process which is taking place from converting of your resources into the good life is nothing but engineering. In this process, who does the person is nothing but an engineer. So engineer is nothing but who invent and do the things in a different way to solve the problems of the nature, the society, and all those things. So that is about the first one. What is engineering all about? And next is what is mechanical engineering is all about. So this is also a very difficult question to answer. The flavor of the thermodynamic subject actually comes from the mechanical engineering itself, where you have your different machines which has been designed by the mechanical engineers, like milling machine, drilling machine, or maybe the turbine, or maybe heat exchangers. All these components are or the machines from the mechanical engineering, which converts your resources of the nature which is being given into the good life. This process which is undergoing is everything under the comes under the mechanical engineering itself. I hope I have cleared the question of the mechanical engineering is all about. And next is what does the where does the thermodynamics come in? These thermodynamics actually, if you notice, some of the schemes which is happening in your mechanical engineering was just before, which I mentioned, the machines that uses natural resources and produce energy, which can use for your daily needs, such as like driving of our cars, running our refrigerators, washing machines, anything that we use. These natural resources are usually in the form of fuel. I put fuel in quotes because even solar energy may be considered as a fuel of some sort. So this thermodynamics, which comes in a place which in which this provide in the energy in the form of heat. Suppose if you stand in a sun, you feel warm. We burn some fuel, it is liberated. Whereas this energy, this machine produce is in the form of work. The science which actually looks at search machines which convert your heat into work, and maybe even vice versa, which is also known as thermodynamics. So basically this thermodynamics is essential, going to look at all these interactions, which is doing some work, and also the interaction doing and absorbing the heat. All this could be machines, this could be gadgets, or this could be anything. In this thermodynamic, we just call this thermodynamic system. We'll define more about these definitions later in the coming classes. Um, uh, Excuse me. And next, coming to the who are the contributors of the thermodynamics. Contributors is like physics, chemists, mathematicians, all these persons who comes under are all the contributors of thermodynamics itself. Next, if you move on to the other one, who are the users of thermodynamics? Uh, all the background of engineering, such as biological one, aeronautical one, civil engineering one, and mechanical engineering one, chemical engineering one, all are the users of your basic thermodynamics itself. And next, if you move on into detail of the subject in the next session, I will catch you. That's it about for your second session of the introduction of the subject. um, Thank you. We'll catch you in the next class.